In this section, we are going to see how does data table work. Data tables is a utility that Excel provides under what if analysis in data. It helps you to see the sensitivity of the result cell in terms of two cells at the same time. Now let us take the basic example of the same. Let us say we have number of people and we have income per person. Now all that we want to do is we want to see the outcome of the data points in this table. Let us say we organize the sample set of data points in this order: 10, 15, 20, 25, 30, and here 1000, 200, 1500, 800, and we can slightly zoom up this entire slide so that it is better visible. So I'm just making it 140%. Okay, now this is much better, so it is much visible now compared to earlier. Okay, I will try to make it 160 in this case. Okay, so and let us say 2000. Now I want the outcome. So this is number of people and this is income per person. Now this is a typical management decision that how many people they should hire against the income per person that they are offering. So let us say they want to hire 30 people at 1000 rupees or 1000 units of salary per month. So this becomes the resultant cell. Now if you want to do this across this data cells, then it's not very difficult. It requires wise use of dollars, but there is another method which is through what if analysis, which makes it much easier. That is what we are going to see in this particular section. So let us see how it works. Okay, so what we do over here is we take a sample data point, anything for that matter, 13 and let us say 500, and I'm saying total income cell over here. This number becomes 13 into 500, which is 6500, and I'm giving this resultant cell over here. Now please ensure that this is actually connected over here, and this number is actual computation of the two variables that we have picked up over here. Also ensure that none of these data points are connected with the original sample data points that we have taken. Like number of people should not be connected with any of the items, should not be connected with 13. Any of the items over here shouldn't be connected over with income per person. Having done this, select this range, go to data, just go to what if analysis, go to data tables. It will ask you for row input. Row input is the reference cell which represents the horizontally aligned items. So in this case is number of people, so I am referring to this, and over here it is the column representative, and which they call as column input cell, and we just press OK. And you will observe that the calculation has been meticulously done. What the function does is it represents or it replaces, let us say over here, it replaces number of people with 15 over here and number of people with income per person with 1200 over here, and whatever the value comes over here gets represented exactly at the intersection of the border cell matrices. So that is how this works. Now let us look at it from the perspective of some different example. Okay, now let us say we want to deploy it for a typical financial problem where we need to compute the stock price using Gordon growth model. Now Gordon growth model requires certain inputs, which includes DPS 0, which I am assuming 100. It requires GN, which I am assuming 5%. It requires let us say RFR, which I am assuming 8.25%. Then it requires RM assumption, which I am assuming 15%. And it also requires a beta assumption, which I am assuming 1.1. Now I want you to calculate the equation of Gordon growth model, which is given by P0 equal to DPS1 divided by in bracket Ke minus Gn. Now to deploy this equation, we need to calculate DPS1 first of all. So DPS1 will be given by DPS0 into bracket 1 plus Gn bracket complete. Then there is calculation of Ke, which is given by RFR plus beta into in bracket Rm minus RFR. So that gives us Ke. We will represent it in percentage format, and then we need to calculate the P0. So the P0 is given by DPS1 divided by in bracket Ke minus Gn. So this is the basic computation that gets done over here. Now this P0 is the ultimate outcome of this computation. So we now want to see the sensitivity of P0 vis-a-vis two parameters. So one of the parameters that I am assuming is Gn, and the other parameter I am assuming is beta. So now in Gn, my basic value is 5%, and my beta value is 1.1. So I am assuming different values of beta as 1.0, 1.08, 1.05 and 1, and over here I am assuming it to be 1.12, 1.15 and 1.20. For Gn, I am assuming values as 4%, 3% on the lower side, and 6% and 7% on the higher side. That's it. Once we are done, you need to do this selection. Ensure that you need to do this selection. Ensure that this cell is connected. Cell at the intersection. Ensure that it has to be at the intersection. You cannot keep it over here and then expect result to come. It has to be here at the intersection of these two border matrices. So you need to ensure that it is connected to original formula. Also you need to ensure that formula is all linked up with all the cells which we are assuming as a part of the computation. For example, if you have, instead of this Gn coming from F24, if you say that I am just putting it as 5%, answer will be still correct, but the sensitivity analysis will not work. So I am just undoing it, and now selecting the range, going to data, going to what if analysis, going to data tables, and giving row input cell as. So my row input cell is the horizontal representation, which is Gn. So this is Gn, and my column representation is given by beta. So I'm selecting beta from over here, and I'm just saying OK, and you would see various values appear over here, right? And what we are referring to is this cell. Which is exactly the value that we have got from the computations that we have done earlier. So this is called a sensitivity analysis. This is many times useful when we go to the fund managers and present your case and represent the values, let us say as P0 as the fair value. But the fund manager doesn't agree with the assumption that you have. He says, I think your beta assumptions are very less. You should increase the beta from 1.1 to, let us say, 1.5 or something like that. In that case, what becomes the answer? So you don't have time to change the models and look into Excel and get back to him immediately. you get hardly 15-20 minutes to interact with him. So if you have at least sensitivity table like this available with you, you can at least give him some range, that if you assume 5% of growth rate, it will be 953 value, and if you are assuming 4% of growth rate, it will be between 866 to 953. So that is how data tables work, and you can use it for multiple places to do the sensitivity analysis. Thank you very much.